Hi class, today we're going to do start chapter 11. We're going to do section 1, which is on area of parallelograms and triangles. And so this should be some familiar stuff, but then we're going to go throw in some of our geometry. And so our objectives today are to find perimeters and area of parallelograms and to find perimeter and areas of triangles. All right, so let's first off just talk about area of a parallelogram. And in the area of a parallelogram, it's going to be the same formula as for a rectangle. Base times height. Here's our height, and our base is on the bottom. The reason why it is the same is if we drop down a line here and take this triangle here and move it over here, then we now see we have a rectangle shape. Also just want to point out with this is sometimes the height is given to you outside of the parallelogram. All right, so first one, find the perimeter and area of each parallelogram. Well, if we look here, perimeter, we know all the sides. This is going to be 10, and across is going to be 4. So if we go ahead and add those up, we get 28 inches. All right, now we need to talk about what's our base and what's our height. Our height is the one that makes a 90-degree angle. So our height is 5, and what it makes a 90-degree angle with is the base, so that 10. So we're going to take 5 times 10, and we're going to end up with a 50 inches squared for our area. All right, if you go ahead and look here at B, we notice that we have a base and our side, but we don't actually have our height here. And so to find our height, we need to do Pythagorean theorem. So h squared plus 8 squared equals 17 squared. Go ahead, pause the video, take a moment, type that into your calculator, get that all figured out. When you finish, you end up with a height of 15. So now we have a base and a height and our perimeter. So I trust that you guys can go ahead and figure out the math for these. So I'm just going to go ahead and give you the answer. 76, oops, not inches, centimeters for our perimeter. And our area is base times height. Remember that height is the 15 that we found. And so we end up with 315 centimeters squared. All right, here's our last one. Notice that we have that triangle on the outside of our parallelogram. That's giving us our height. This is our height. We are missing this side here, so that's going to put a cramp in figuring out what the perimeter is. So to do that, you're going to do Pythagorean theorem. And our hypotenuse ends up being our x squared. And I'm going to leave that for you guys to go ahead and find the x so that you can find the perimeter and then go ahead and do the area. All right, so let's talk about finding the area of parallelograms using special right triangles. So notice that we have 45 degrees here in that angle, and that's going to help us find our height. We need another side in that triangle, and so we're going to have 9 because we get that from here. So you can either use your special right triangles or you can use trig. And if you use trig, we notice that we have our opposite and our hypotenuse. If you use special right triangles, why don't you put your answer into a decimal so that it's easier for us when we multiply. So go ahead and find your height. So if you don't have it yet, pause the video. All right, 6.4 we find for our height. So now we're just going to take base times height. So our base times our height, and we get 76.8. There isn't a label here, so we don't need to put one. All right, next problem here we see is a 30, 60, 90 triangle, and we have we need to find, because we're just finding the area, we need to find our height. So you can either use 30, 60, 90s, so you're given the short leg and you want to find the long leg, or use trig and you have your opposite and your adjacent. Go ahead and try that one on your own. Let's move to the back side and talk about triangles. We all know that the area formula for a triangle, there's 2 ways we can look at it. Base times height, divide by 2, or 1/2 base times height. All right, and in our triangle, again, the same thing with the parallelogram is our height makes a right angle with our base. So here's our height. Sometimes it's outside the triangle, and there's our base. When we find the perimeter and area of each triangle, we're finding it of the shaded triangle. So if we look at our shaded triangle, we are actually missing a side here, so that's going to not allow us to find our perimeter. But We do notice that our dotted triangle gives us a right angle, so that's a right triangle. We can find that missing side. So 27 and 30 are our legs, and x is our hypotenuse. If we go ahead and do Pythagorean theorem, you end up with that missing side being 40.4. So we're finding the area and the perimeter of the shaded figure. So for finding our perimeter, we're going to add the shaded figure sides. And when we do that, we end up with 100.4 inches for our perimeter. Now here comes the tricky one, is asking you guys about finding the area. What is our base? What is our height? Remember, height is the one that makes the 90-degree angle. So our height is actually outside of the triangle, and that's 30. And we're going to times it by our base, which is the one that it makes the right angle with, and so it's that 19th. Even those two do not touch, those are the ones we're going to use. And then divide by 2. We end up with 285 inches squared for our area. All right, looking at this next problem here, we need to find perimeter and area of each parallelogram. And we have 2 pieces missing in our shaded. We're missing our height, and we're missing this side over here. So we are going to use Pythagorean theorem to find both of them. First, you're going to use our small triangle here. And notice that our hypotenuse is that 13. Okay, and once you find the height, you're going to plug that back in there. And now you're going to do Pythagorean theorem again to find your perimeter and your area. All right, you need to buy enough boards to make a frame of a triangular sandbox shown and enough sand to fill it. If one board is 3 feet long and 1 bag of sand fills 9 square feet in the sandbox, how many boards and bags do you need to buy? Well, when we're dealing with boards, we're actually talking about perimeter. So we're going to find the perimeter of the shaded figure. And perimeter, we're just going to add up all the sides of the shaded figure. And for our perimeter, we end up with 35.5 feet. But we want to find out how many boards we need to buy, and each one is worth 3 feet. So if we take that 35.5 feet and divide it by 3, that's going to tell us how many boards we want. And 11.8. We probably aren't going to buy 0.8 of a board, so we're actually going to round that up to 12. All right, now let's talk about it says that 1 bag of sand fills 9 square feet. So we're talking about square feet. We're actually going to find our area. For our area, we're going to take our base of 12 and our height of 9. Remember, it's the one that makes that 90-degree angle. Divide by 2. And we end up with an area of 54. We don't need 54 bags. 1 bag fills 9 of those feet. So if we take 54 and divide it by 9, we are going to have to get 6 bags. All right, find the value of x. So we have, for 5 and 6, we have to find the value of x. Here we notice that we are actually given the area, and we're going to be expected to find the height. So think about area formula for a parallelogram, base times height. Let's fill in what we know. Our area is 148, and our base is 8, and our height is x. If we want to have x all by itself, we're going to divide both sides by 8. And x ends up being 18.5, and we can label with meters. All right, try the same thing with 6, except for it's a triangle. So you're going to be using area equals base times height, divide by 2. Plug in what you know to solve for x. All right, the base of a parallelogram is twice its height. If the area of the parallelogram is 72 square feet, find the base and height. So let's draw ourselves a picture. So our base is twice the height. So if our height we call h, the base is going to be 2h. And its area is 72. So area formula for a parallelogram is base times height is equal to our area. So let's go ahead and simplify. We get 2h squared equals 72. But we are going to have to solve for that h. So 2 ways we could do this. 1, we can go ahead and divide both sides by 2. So we get h squared equals 36, and take the square root of 36, and h equals 6. So our height is 6, and our base is twice that. So our base would be 12. All right, there's no label. Oh, feet. There is a label. Okay, that's probably the easiest way that we can see about doing it. The other way would be at this step here, instead of dividing by 2, if we went ahead and subtracted the 72 over. And now we're going to do some factoring. If we factor out a 2 out of both of those, we get h squared minus 36 equals 0. We know right there that that h squared minus 36 turns into, it is a difference of perfect squares. So we get h minus 6 and h plus 6 equals 0. Zero product property says that we would take each set and set them equal to 0. Well, 2 cannot equal 0. If we have h minus 6 equals 0, we end up with h equals 6. That works. And h plus 6 equals 0, we'd end up with h equals negative 6. Can't have a negative height. So again, we see that our height is 6. So 2 different ways to look at it. All right, guys, that wraps up our video. Finish up those problems for the next day.